day everyone, this is Jesamie Ceniza, your instructor for today. So before we start, let's have our opening prayer. So we will no longer have a recap of the last topic because we already did it last week or last meeting, okay? So now let's proceed to our next topic. So our next topic for today is all about the transformers. So our objectives for today is to identify and familiarize the type of the transformers. So to know and identify the parameters being considered in the transformer design. So since this is an electrical installation and maintenance subject or course, so let's focus on the electrical transformers. Okay, electrical transformers are machines that transfer electricity from one circuit to another. They are used to design AC supply, which means that fluctuation in supply voltage is impacted by the fluctuation in the current. So an increase in current will bring about an increase in the voltage and etc. So now let's proceed to the types of transformers. We have power transformers, auto transformers, generator step-up transformers, and auxiliary transformers. So let's discuss first the power transformers. Power transformers transfers electricity between a generator and the distribution primary circuits. So it gets a little bit confusing because many use the term power transformers to encompass a bunch of transformer rather than a specific type. So likewise, some even refer to large transmission transformers as power transformer to easily differentiate between distribution transformers. And by the way, power transformer can also fall into one of two classes, the class 1 or class 2. Very original naming system, I might add. Anyways, class 1 power transformers have high voltage windings of 69 kV or kilovolts below, while class 2 power transformers have high voltage windings between 115 kilovolts and 765 kilovolts. So just to make things a tad more complicated, you can also categorize this by size: small, medium, and large. Small power transformers fall under 69 kV, medium up to 230 kV, and large power transformers are between 138 to 765 kilovolts. Now, let's make things even more complicated. Let's proceed to the second type of the transformers, which is the auto transformers. So auto transformers technically fall under the category of large power transformers, but these are generally used as transmission enterprise transformers, which can be used in either step-up or step-down mode. Now, what's an enterprise transformer? Very great question. Now, an enterprise transformer helps connect the networks of various voltage to each other, which is really important feature in a power network. Now, the third type of the transformer is the generator step-up transformers, which is the main or unit of the transformer. So GSU, or the generator step-up transformers, is connected directly to the generator. It's also typically operated at a constant load close to their full rating. Since they're constantly working at a rated temperature, they're going to age much faster rather than other transformers. If you read any of these blogs before, you'll know that excessive heat is never a good thing. unless if you are a cactus. So we are now in the last type of the transformer, which is the auxiliary transformers. And by the way, for the information of everybody, there are few different types of the auxiliary transformers to keep track of. But fortunately, we have more acronyms to make our life easier. So we have UAT, or the Unit Auxiliary Transformers. Now UAT, or the Unit Auxiliary Transformers, is connected to the same bus as the generator, stepping down voltage to feed the auxiliary power system buses. So that is the UAT, or the Unit Auxiliary Transformers. Always bear that in mind. We have also the RAT and the SAT. The RAT is the Reserve Auxiliary Transformers, and SAT is the Startup Auxiliary Transformers. They are both the backups of the transformers, which are connected to an off-site high-voltage system supplying the plant auxiliary power during startup or outage period. So those are the types of the transformers. Now, let's proceed to the design parameters of transformers. Now, in designing a transformer, we need to, who can guess? We need to, yes, exactly. First is power rating. Second is the voltage level, primary and secondary. The third is current on both sides. So the fourth is the primary and secondary coils wire diameter or size. And the fifth is the iron core area. So number 6, or the last one, is the number of turns, primary and secondary. So we'll no longer discuss further to this because the next reporter will continue. Thank you for watching. I hope you've understand and learned something for today. Bye!